Welcome and hello. This is a video exercise on HEC ResSim. And in this exercise, I'm going to be doing an exercise using scripted rules. We're starting from scratch with a brand new exercise. All right, so I got ResSim open up on the screen here, and I'm going to go ahead and click File, New Watershed. Make sure that you're in the Watershed Setup module here in the top left. Then go ahead and give your watershed a name. All right, then select the directory you want to save that watershed directory to, and then select your units and then the time zone, then click OK. All right, the watershed's been created. I'm going to zoom in and sketch out a stream alignment. So I click the stream alignment tool. I'm going to hold down Control and then single left click on the upstreammost end of the stream alignment. And then continue holding down Control, and then finally let go before your last click, and then give that stream a name. I'm going to add a couple of computation points. So right click, and we'll call this CP1. Then I'll add a reservoir. So I click this reservoir tool. I hold down the control key, left click, let go of control, left click again, downstream, and that will be called reservoir 1. Sure. And one more computation point. I click this computation point tool down here on the bottom left, and then hold down control. I'll call that CP4. All right, next I want to create a configuration for this watershed setup. So I'll say configuration new. I'll just call it config1. All my names for these things are very boring and generic because there's only going to be one of them, and this exercise is very isolated to something not related to the setup so much. All right, so let me go ahead and save the watershed and then move over to the reservoir network module. So I need to create my network first based on that configuration. So we see the projects that we have already added. Call it network 1, and then OK. Here's the reservoir and the junctions. So I'll click the reach tool here on the left, and then single left click. Oh, sorry, got to hold down Control, single left click on the upstream junction, let go of Control, and then click again. And then give the reach a name. I'll do the same thing here. All right. On the junction, I want to assign an inflow. So I'm going to right click, edit junction properties. And then on the local flow tab, I'm going to select inflow at CP1 with a factor of 1, click apply. Okay. Now what I want to do is create the time series that will connect to the alternative and add the water to that CP1 junction. Because right now we just gave it a label, which was really just an identifier for a time series to later be associated with it. Let's create that time series data right now. So I'm going to go up to Tools and then HEC DSS View, File, New, and then I'll give my DSS file a name. I'll just call it Data. Okay. Data Entry Manual Time Series. So now I'm going to fill in some of the parts to the path name here. I'll just be generic and call it project, or B will be like the location within that project. C is the parameter. 1 hour time step is fine. And then I'm going to call this 3K as my user defined value because it's going to be 3000 CFS. So the units are CFS. The start date, I'm going to do the first half of the year now. So that would be 01 Jan 2024. And start on the first hour of the month. I'm going to click this automatic generation tab here and type in my value of 3000 CFS. The last hour of the first half of 2024 would be June 30, and that would be 2400 hours. All right, so if I tab off of that, I can click this generate button, and it generates me a 3000 CFS flow for every hour of the first half of 2024. All right, so I'm going to go ahead and click save and then no. It sort of divides those records into months, so that's fine. All right, so what I want to do now is come back to the reservoir network, click reservoir, and then edit reservoir properties. Here we have a dialog box for us to edit the reservoir. So I'll click on pool, Control V to paste in values I had saved on my clipboard that I had prepared over in Excel. So you can paste values in, you can type the values in if you want. The top elevation is 1500 here. So I'm going to go ahead and set that to the elevation of top of dam. And then I'll just make up some length at the top of the dam. And then I want to add a power plant. So this exercise is going to involve power. Okay, I'm going to paste in the max release. I'm in the outlet tab here, the first tab of the power plant, and I'm pasting in the max release in CFS based on the water surface elevation. The next tab over is capacity, and I'm going to select that the capacity is based on function of the operating head. And then I'll paste in some numbers here. The capacity doesn't actually start till 60 feet of operating head, and then it goes up to 150 feet. The next tab over is efficiency. And as before, I'm going to select function of operating head, and I'm going to paste my numbers in here. Okay, so the efficiency tops out around 90%. Then for station use, I'm going to just say 0. It's not going to be considered in this exercise, so that's fine. And then I will click apply. Also with the power plant, I need to set a tailwater condition. So I'll say tailwater elevation, and I'll just keep things simple and call it 1350 and apply. All right, next over on the operations tab, the first thing we'll do is select new, and then I'll call this operation set 1. So we're creating an operation set. Here are the default zones. We're going to just stick with those. So constant inflow. We're also going to have a constant top of zone elevation here. This will be 1500 as the top of the flood control zone. We're going to say 1480 will be the top of the conservation zone. And then for inactive, we'll say that's 1350 and click apply. One thing I want to do is set a minimum flow. So we'll just do a generic add rule function release. I'll call it min 2000 CFS. That'll be for, let's put it through the power plant. And then, yeah, release function is what we want to use. So I'll click OK. And then it's going to be a minimum all year long. So we can just say it's based on date and then set 2000 for our January 1 date and apply. Add rule to all zones, apply. And what I want to do first in the very first simulation is just run a simulation to see what happens without any scripted rules. And then I'm going to add some scripted release rules in order to improve the power situation, or at least modify the release through the power plant and see if we can get more water or more power. I'm going to click OK here. Next, I'm going to click alternative, edit, and then alternative new. All right, so we'll just call this base case. Okay. And then this will be a 1 hour time step. For operations tab, I'll select my operations set. For look back, the pool elevation, I'll start at the guide curve elevation of 1480. And then the release will start at 3000 CFS because that's the constant inflow anyway. So that makes sense. And we'll save the alternative. I'm going to save the network while I'm at it. Save the watershed. All right, everybody saved. I'm going to select the simulation module now from the drop down. And the first thing I want to do here is create a simulation. So I'll call it simulation 1. And then again, this is the first half of 2024. So got to keep those dates in mind. January 2024. So I'll start it at noon on the first day of the year. And the look back period will start on the very first hour of the year. So we'll have about half a day of look back period. The last day of the first half of the year would be June 30. And then let's just end it at noon as well. All right, so I'll select the checkbox for my base case alternative down here and then click OK. And we are good to go. All right, so we have a water surface elevation of 1480 and 3000 CFS with a tailwater of 1350. So that'd be a 130-foot head. And we could do the math and figure out the power, but let's just run the simulation and see what it gives us. So I'm going to go right click and compute. And there's a problem with the time series records. So hold on. I forgot to assign the time series. So there's no float CP1. Let me go edit run. This is how you edit the alternative editor. And then this tab here. Yep, I forgot. I don't know why I keep forgetting. So go ahead and select that infloat CP1. It's waiting for us to give it a record here. And then click this select DSS path button. And then we're going to open up that file, the data.dss file. It's right there. And then here is our record that we created. So set path name, clicking that button is all we need to do. So close that. The record is assigned and we will click save. All right, let's go ahead and run it now and see what happens. Okay, so it's looking for this DSS path in this DSS file. So I'm going to double check that. I'm going to go over to DSS view, and then I'm going to open. And then here is the file that we created. And then here are the 6 months of inflow. So I'm going to select those, edit, copy to. Now we're going to go into the RSS directory, simulation1 directory, simulation.dss file, and then click open. What it's really doing is copying. And then, okay, yeah, it wasn't there. Okay, let's run it, and it works. Weird. All right, so let's go ahead and take a look at the results. So here is the plot. It's pretty boring. We have a constant elevation of 1480 in the pool, and then a constant flow or inflow and release of 3000. Let's go ahead and check out the numbers. And for this exercise, I'm going to look at the power data by clicking reports and then power summary. And what I want to do here is just see that we have a average power generated of 20 megawatts, and that is a suspiciously round number. I think it's running up against our total capacity of 130 feet. So let me go ahead and check the power plant data real quick. The capacity for power generation at 130 feet, it's probably 20. We need to up that number. So edit run, reservoirs, power plant, and then click on this capacity tab. And for 130 feet of head, we're bumping up against that max capacity. So let's just increase these numbers, and then that would allow us to actually get the full power from the water we're sending through the power plant. It looks like our power plant is a little bit undersized with these numbers here. Okay, I got the new numbers on my clipboard and paste. So we basically increased the power capacity up to what is now going to be 100 megawatts for that 130-foot head. That should be plenty, but let's find out. So I'll click apply and then OK. And then let's compute again, and then close that. And then let's look at the power summary here. Okay, that's more realistic. So we have an average power generation for the month of 29.69 megawatts. Okay, so before we actually add some scripted rules, I want to see what effect the head has on the power generation. And if the hydropower equation, it is linear with head. So this is 1480. Let's go ahead and do 1470 and also 1490. So hang with me real quick. I'm just going to modify this base case and go reservoirs, click on physical, nope, operations, conservation zone, because this is the guide curve. I'll do 1470 first and apply. Okay. And then I also need to go alternative editor, look back. We're going to start at 1470. All right. So alternative, save. Okay. And then we'll compute, close, and then reports, power summary. Now we have 27.41 because remember that head loss, the power head is 120 feet. We're not including any minor losses like through the penstock or station loss, but this is 27.41. We'll just go with that. Okay, real quick, now let me just do 1490. So I'll go reservoirs, conservation zone. We'll change this to 1490 and apply. And then again, the look back water surface elevation will start at 1490 and alternative save. Okay, and compute. All right, report power. Now we have 31.62 megawatts, which makes sense. What I want to do now is release as much water as possible. Start it at 1500 at the very top of the dam, release it down to say 1440 could be our first trial, and then see what the power does. All right, so to do that, I'm going to actually create a trial based on this base case. That way it'll make a copy, and I'll just call this script. Okay, go ahead and edit run, reservoirs, operations tab, and now I'm going to right click, add new rule. I'll call this power script rule. All right, and then I'll select the power plant, and then from the rule type, I'll select script. Okay, now the script pops up. Okay, I resized the script, and here we have our boilerplate script. Actually, let me come over to the left here and remember to add the rule to all zones, because I am pretty good at forgetting that. Okay, we're set there. Now we have the initial rule script, which runs once, and then the main rule run rule script, which runs each time step. And we have our return value, which is currently setting the maximum release to 1000 CFS. We will not do that. We will get back to that to actually give it a release value. But right now we're going to come to this part of the code where it says add your code here. And what I want to do is a few things. First, I want to get the water surface elevation. And if it's at 1500, I want to start releasing water. And if it's down at 1440, the minimum value that I said, we'll stop the release and then just let the water increase in elevation and repeat that process. So water surface elevation is one thing I'm going to need. It's a time series. So I'm going to go up to model variable, reservoir, reservoir one. It's the only reservoir I have here. Let me give myself a little more room. And this is the elevation, so pool elevation. So put my cursor where I want that code to input, double click, and then boom, got my time series here. So the actual water surface elevation, I'm gonna actually make a comment here. So this is gonna be water surface elevation previous, previous. Now what I want to do is get the time series, the value from the end of the previous step. So over in the API tree, I'm gonna go down to APIs, time series, get previous value. So let me put my cursor there, double click. Great. And then the parameter is going to be this runtime step. So that is this right here. Copy and then paste. And I am good to go with my water surface elevation previous. All right. Next, I want to get the max release that's possible to release water from based on that water surface elevation. So I'm going to just say max release equals get max release. There may be a function in ResSim that does this, but we can do it ourselves. So I'm going to pass it the water surface elevation previous, and then that's all I have to do there. But I need to write this function, so let's go ahead and do that. Okay, let's find a place for that max release function. I'm going to put it right here. So I have it saved on my clipboard. I'm going to paste it in line 23, paste. So here's the function I just pasted in. You can pause the video if you want, but what we're looking at here is the elevation and max release that we already pasted into the reservoir for the power plant. So at 1400 CFS, there's a max capacity of 0 release. And as the elevation in the reservoir pool increases, so does the maximum allowable release from the power plant. All right, so what I'm doing here is I'm creating a paired value set object. This is in the documentation, the APIs. And then I'm setting the interpolation type to linear. And then I've got my paired data. I'm adding the pairs to that's this method here. This is just Python code. It's just looping through these lists. And then the last step here is to actually perform the interpolation based on that water surface elevation. So I didn't want to spend time typing it all, so I just will be pasting in certain parts of code in this video. So this will give us the maximum release of water through the power plant based on the water surface elevation. Okay, the next thing I want to do in our main function here after max release is to determine if the current operation is generating power or not. Is water flowing through the power plant, or is it holding back and only releasing the minimum 2000 CFS? And to do that, I'm going to create a state variable, a scriptless state variable to keep track of whether or not we're generating power at the max flow rate or only at the minimum 2000 CFS flow rate. So I'm going to go ahead and say gen pow previous, and this is going to be gen pow time series. And now I want a state variable, which will be here, but doesn't exist yet. So let's go ahead and save our code, create the state variable, and then come back here and resume coding. I'll click apply and then OK. All right, so I'm going to go up to edit and then state variables. Okay, so the state variables are up here. I'm going to start by going state variable, new, give it a name, generating power. I'm going to use the same parameter name just to keep it consistent. And then this is going to be a 0 or 1. So it's not going to have units, just binary basically. I'll just say count. I'll remember that. And this is going to be scriptless. So no scripting going on right here. State variable, save. Okay, so I'll close that. Then let's go back over to our reservoirs and then the power script, gen power previous. Okay, so I'm going to go and get that time series. So now we have, if I click state variable and expand, I see my generating power time series, and then boom. Okay, so now I'm going to say gen pow previous equals gen pow time series dot, and then now I need to get the previous value. It's going to be the same thing as this right here that we did for water surface elevation. All right, so we have those three things. What else do we need? We need some actual logic now to calculate the release. Now I realize some of this operation I'm doing in this exercise could probably be done using scripted release rules and if blocks. I haven't thought about it hard enough to confirm that or not, but this is an exercise on scripted rules, so we're doing it this way. Release. And now we want to, let's see, the first if statement would be like, if the water is at 1500, then we want to release. So if water surface elevation equals 1500, actually, I'll say at least 1500 because the model will possibly push it over 1500 by just a little bit. Then we'll say the release equals max release. Also want to assign the variable generating power, gen pow, and that's going to be 1. All right, next I want to do an elif statement. Water surface elevation is less than 1440. Then that's when we stop the release and we set the release equal to 0. Now we already have another rule in the rule stack that says minimum release 2000 CFS, and that's fine. That will govern over this release of 0, but this particular scripted rule by itself will say release of 0 or 9. Let's go with 0. Gen pow is going to be 0 as well. And one thing I want to change about this is I'm going to just create a variable for the max. I'm going to say WSEL max, and that will be 1500. And then we'll do the same thing for min. Okay, parameters. Limits might be better. Okay. All right. And we have another if statement because if the water surface elevation is between the max and the min, what we're going to do is we're going to look at that previous power gen value. And if it was generating power before, we're going to continue generating power, which means water surface is going down. If it wasn't generating power in the previous time step, we're going to continue that operation and water surface level is going to be increasing. So I'll just say else here, and then I'm going to say if gen pow previous equals 1, which means it's generating power, then I'm just going to use the same thing I did here, keep releasing, and then the else here, I'll copy this and boom, indent. All right, so we have our release and we also have to write that gen pow. So let me do release first because that's on my mind and that's easier. All right, so instead of 1000, I'm just going to go, actually, let me comment this out so I can preserve the original suggested code that they provided. And then I'm going to paste the same thing down here, release. So let's go with that, paste. Okay, so this is our release. And now the last thing I think we need to do is create is to update this generating power time series with the value so that the next step we can actually extract the previous value, if that makes sense. So we know what the value is here. We're assigning it either 0 or 1 based on these if statements. I'll call it update generating power gen pow time series equals, we'll just double click up here. Now I know we have the exact same line up on 67, and that's fine. I'm just going to kind of be explicit and write it again. So I'll go gen pow time series dot. Then let's go into our time series API here, and we want to set the value. I'm sorry, I did some research, and I think what I want is state variable set value here. Oh, that's set value range, set value here. This is the one I want. All right, my bad. Let me go ahead and delete that and then double click here. It's set value inside of the state variable class, which is in the APIs. Oops, didn't take. Double click. Okay, we're good. And then what it wants is the value here. This is going to be gen How here is the same time step, current run time step variable, and we'll paste that in right here. Paste. All right, let's go ahead and click apply. We might as well click this compile script button and fingers crossed. Oh my goodness, it worked. Okay. The water surface elevation is basically going to oscillate between 1500 and 1440. Once it hits 1500, it's going to release water until 1440, and then it's going to go up and down over the course of the first 6 months of 2024. So let's go ahead and compute. Okay, what happened? Okay, so what happened is, that's right, I need to include the paired values extension, which is just a module that needs to get imported. All right, I knew there was going to be something. Let's go ahead and click reservoirs, back to our script. What I need to do up here, paste in this paired values extension, because I didn't really talk about it too much, but this paired values extension class is how we're doing the linear interpolation. And if you paste that in, search for Google, you can get all the information about that API you want. So for instance, what I'm seeing here is the paired values extension. And then down below, we have the definitions of all the methods and their descriptions here. So what we did was, so set interpolation type was one method, and we set it to linear. And then the other method was add pair data. And then the last one was interpolate. So we could find those here. In fact, add pair data would probably be at the top if it's, yeah, add pair. Is that what it's called? Yeah, add pair. So we have an X and Y pair, we send it. And then the interpolate function would be further down. And then here's the interpolate function. So you just give it its X value and it already has the stored paired data that you're comparing it against. All right, enough about that though. Let's come back to the code and click apply and then OK. And then let's go ahead and run it. Ooh, global name water surface elevation is not defined on line 74. Water surface, oh, this has to be previous. Okay. Paste the value. That was just a typo. That was just clumsy. So apply. Let's check the script. That looks good. Okay. Let's see. Third time's a charm. Looks good. All right. Let's go ahead and peek at the reservoir data. And let me toggle that off. Plot. All right, very cool. So what we have on the top plot is the water surface elevation, just oscillating between 1500 and 1440. And then we see the power on the bottom. No, sorry, the bottom is the flow, and this is in CFS. So we have, it tops out, looks like whatever the maximum flow associated with 1500 is, it looks like it's 5500. And then down to 2000. And then it just does that over and over for the first 6 months. All right, so let me go ahead and go report and then power summary. What we have here is an average power generation of 28.19 megawatts. So what I want to do is a couple more trials. I'll keep the top limit at 1500 feet and then change the bottom limit a little bit higher to maybe 1460 and then 1480 feet. We'll get all the numbers, we'll look at the results, and then we'll call it good. All right, so I'm just going to use this same trial and just make a few edits. I'm going to go reservoirs, go ahead and click on the script, and then we're going to change that lower limit from 1440, 1460 now. Apply, OK. And then I'm going to compute, close. I'm going to take a look at the plot real quick. The water surface elevation is only going down to 1460 now. There's probably more cycles. We'll go reports, power summary. It should be more than last time, and it is 30.05 as our number of megawatts, which is the average power generation over that 6 month period. Okay, the last one I want to run is the setting the minimum to 1480. So we'll go reservoirs, and then the script again. We'll change that to 1480, and then apply. Okay, compute, and then close. And let's just check the plot. 1480. That looks good. And then we'll go to our report and then power summary. And then here we have a total of an average, I should say, of 31.63 megawatts of power generation when operating between a water surface elevation of 1500 and 1480. Okay, we're back at the Excel, and this is the final results. Our first trial was these first three constant water surface elevations at 1490, 80, and 70 with these average power generation. And then what we did was we started at 1480 and then oscillated between the top of water surface elevation 1500 up down to 1440, 1416, and 1480. I also off camera did a separate trial with keeping the water at the very top of the dam at 1500 constant. Okay, so the results I can draw from this is say 1490 and generates 31.62, which is really essentially the same as 31.63. And 1490 was what you could say the average between 1500 and 1480. So what I thought was going to happen was that there would be more power generation from sending higher flows through. But I guess that sort of cancels out because this trial here will have a longer time period of flowing the minimum of 2000 CFS, which would not be a lot of power generation. So again, 1470 of 2741 is actually quite a bit less than doing the same thing between 1500 and 1440, even though that splits the difference. This is just a way to run some analysis and run some numbers using scripted release rules in HEC ResSim.